Hello dear students. In this video we are going to learn about the important chapter of inorganic chemistry, that is p block elements. So what are p block elements is, you know that in the periodic table we have been classified the elements into different blocks, that is S, P, D, F, like that. So how these are classified is, you know that if the outermost electron, if it is entering to the S orbital, then we are going to call it as a S block. If it is entering into P, then P. If it is entering into D, like that, we have been classified them into S, P, D and the F block elements. So in the periodic table, the groups, that is from 13 to 18, we have classified them as a P block elements. In your 11th standard class, already you have learnt 13 and the 14 group elements, their physical properties, their chemical properties. So here we are going to learn the P block elements from 15 to 18. Okay, so this we are going to learn. The main objective of this lesson is that by the end of this you should be knowing all the physical properties, chemical properties, some of the important uses of these P block elements. That is the main objective of this. Okay, then coming for like in the periodic table where we have placed these elements is, so group, that is 1 and the 2, where the left side of this periodic table, these we are going to call them as a S block element. Okay, here at the center we have placed these D block elements, and here we have placed the F block elements. Okay, then at the right side of the periodic table, that is from 13 to 18, here we have placed the P block elements. Okay, so these are the where they have situated in the periodic table. The first and the second group, they are called as the S block, and in between the S and the P there is a D block element. F block elements are separately placed at the bottom, and P block were from the 13 to 18 group elements. Now the question is, why we have to study these P block elements? These P block elements, they are very important. For example, if you consider fertilizers, where they add to the growing of the crops, where there is an essential element like phosphorus and the nitrogen. That is one main important use. That element is nothing but a P block element, and the important layer of the stratosphere, that is ozone, which protects from the UV rays, that is O3. That is oxygen, which is nothing but the P block element. Okay, and then in this refrigerator, we are going to use it as a refrigerating agents. So there the nitrogen is the main essential thing. So there is a huge application of these P block elements. So we should know all the uses and where these compounds of these elements are also being used in many other things. For example, in the fuel or in the propellants also these elements are being used. Okay, so this is all just about the introduction of these P block elements. So one important thing that you are going to learn in the P block element is very important, that is inert pair effect. So before starting with the chapter, so now let us study what is this inert pair effect. Okay, so you have learnt about the definition and then the other things in the starting of the P block elements. So here once again I'll clear this inert pair effect. So what is this inert pair effect is? First thing that you have to keep it in mind is this inert pair effect. This is applicable for the P block elements only. This effect is not seen by the S, D or any other block elements. Mainly if we can restrict it is from the 13 to 17. So group 18 as they are inert, so we are not going to explain the inert pair effect for this. So 13 to 17 elements, they will show the inert pair effect. Now the question is, in simple, first you see the elements like this: carbon, nitrogen, oxygen. When I write the electronic configuration for this, so carbon 1s2, 2s2, 2p2, nitrogen, the atomic number 7, 1s2, 2s2, 3, 4, 5, 6, 7, oxygen 8, 1s2, 2s2, 2p4. Okay, now, so I have written the electronic configuration for this. If I restrict this for the, so the group 15 elements, that is nitrogen, phosphorus, arsenic, antimony and bismuth, I have written these elements. Similarly, you can write the other elements also. So for this explanation, I have taken the only group of 15 elements. Okay. Now, as I have told you, the oxidation state, that will be decided only by the valence electrons that are present in the element. Okay. So nitrogen, I have written here the valence electron is, that is 5. Okay. So the maximum, the oxidation state that will be seen in this is, that is +2, +3 and +4, like that. Okay. But the starting of the elements, they will show the oxidation states as +3, +4 and the +5. But as we move down from the first element to the last, that is as we move down the group, no, what happens here is the oxidation state, instead of increasing, there is a considerable decrease in the oxidation state. That is, when we compare the nitrogen and phosphorus, they will show the oxidation state as +3, +4 and the +5. Whereas the bismuth, it will not show the oxidation state. This effect, no, this is applicable for the even other group elements like 16, okay, 13, 14 as well. Now, why is that there is a decrease in the oxidation state is, you know that as we move down the group, there is a nuclear charge that will be continuously increasing. That is, increasing the nuclear charge. So what happens if the nuclear charge is increased? You can see here, there is a 2s2, 2p2. Okay. As we move down, the S block elements, if the nuclear charge is increasing, the nucleus will tend to attract these electrons towards itself. As a result, what happens is the S block, that is the S electrons that are present in this orbital, no, they will not be taking part in the chemical bond formation. They will become as a inert, means they will be inactive. So inert pair effect is nothing but the incapability of the S orbital electrons to participate in the chemical bond. So they are not participating. As a result, what happens? There is a +2, that is 2 oxidation number will be reduced. That means, for example, if it is having a it is having a 5 oxidation state, just for the example I am explaining you, it is having a 5, then the bismuth oxidation state, or the, as we move down to the group, no, there is a -2 oxidation state. That means lesser than 2 unit lesser than it, the above elements oxidation state will be seen by this. Okay, so this is, we are going to call it as a inert pair effect. The S orbital electrons, no, they become inert. Only the p orbitals electrons that are present, no, they will be involving in the chemical bond formation. That is why the oxidation state will be reduced. So what is inert pair effect is, the S orbital electrons, they will become inert, or the incapability of these orbitals electrons to participate in the chemical bonding formation. So this we are going to call it as a inert pair effect. You have to remember this. This is very important. So in the entrance examination, they may give you the 4 elements and they'll ask you what will be the oxidation state for this. So how you have to remember here is, if the, for example, if the element, if it is belonging to group 7 or it is 6 or the 5, okay, what you have to do here is the group number, okay, -2. So this will give you the oxidation state for the elements where if they are showing the inert pair effect. So you should know that the p block elements, if they give you and ask you to identify the oxidation state, the group number you should know for that element and -2, that will give you the oxidation state.